So today we're going to be creating a 2D top-down movement controller, which will try to emulate the old style of movement, 4-axis, so up, down, left, right. And it will have collision detection, so as you can see, it doesn't move past the rock. And it will also be as responsive as possible, but still use the tiles as a guide on how you'll be able to walk. So you will only be able to walk one tile at a time, but you will have quick access to change directions. Along with that, we will be calculating the animations, and we will also be able to change the distance. So if you want to change, for example, the distance to be 3 tiles long, as you can see here, that's 3 tiles long, or maybe even make it 0.5 tiles long. Yeah, so we can also change the moves per second, which means how many tiles we move per second, so we can make this 6. So as you can see, that's the normal speed, but we have a lot more precision in our controls. But we can make it also be 1 and make this 3, so now it moves 3 tiles per click, but we can also change the direction real quickly. As I said earlier, that was a feature. And yeah, that's pretty much what we'll be making today. Okay, so let's get started. First of all, we need to create the tile map for our game. So we will go to the game objects, 2D, and let's create a tile map. Great, let's name it tile map, that's cool. So now what we want to do is go to the window, 2D, and go to the tile palette. We will put this here so that we can check it out. And now it says create a new palette in the drop down above. So to do that, we go to our ground tiles, and we put a tile, we drag and drop it, and we put it here or not, no. So we create a new palette, let's name it 2D palette, I guess, and let's create that. Great, we will create a new folder for our palette, let's name it palettes, and now we go and choose that. So now we drag and drop our sprites like this. We put that on our palettes folder, and we create and we press save. So now, as you can see, we have our palettes, which we can use to draw by clicking and dropping, sorry. And as you can see in the game, that's how this looks. Let me put this here so that we can check it out later. And 16 by 9, and let's put some other tiles as well. Okay, so I went ahead and put some more tiles here. So let's create this to make it look a little bit better, I guess. Okay, this looks pretty fine. We can actually use these tiles here to make this look a little bit nicer, like that. And yep. Sorry. Yes, let's make the edge as well. Alright, so we're good. So now we can put our tile map on 0.5 for a reason that we will see later. And let's put our character as well. So let's grab this and let's put him there. So this didn't work, but this still doesn't work. So that's because we have our order layer as 0. So let's put this at 2. And as you can see, we have our character here. So let's put this at 0 and 0. Okay, that's perfect. And as you can see, our character seems a little bit blurry, or if it doesn't, that's because we need to disable the bilinear blur. As you can see, now it's blurry, and if you disable that to wrap mode to be point no filter, that's gonna be 0. So that's what we want for a game of this type. And okay, let's see what we'll have here. Okay, so 0.5. All right. So as you can see, our player is in the middle of here. So our player our player pivot is in the wrong place. We want it to be in the middle. So let's change that. So we will create the player, and that's an empty game object. As you can see, we just delete everything that it has. And so now we put this in 0.5, I guess. No, minus 0.5. So let's see if this works. Perfect. So let's see now. The tile map is in the middle. So yeah, that's perfect. So now we want to start and make our script. Okay, so let's create a new script, which we will call PlayerMovement. Create and add. Perfect. So now we open it with Visual Studio. And so now we start by actually calling our sprite renderer, so public sprite renderer sprent. And so now what we want to do is basically go to our character and start moving him based on how we press the keys. So we go to our void update, and now we want to get our vertical input, which we will get with input.getAxis, and same with horizontal. Okay, perfect. So now what we want to do is actually start moving our character. So to do that, first thing we want to do is create a new enumerator, which will basically calculate our position. So we will go here to public enum, which we'll call direction. And this will contain all the character directions that our character can go, which will be top, no, actually up, down, left, right, and no direction. Perfect, so we need to close that. So now we go and actually call that enumeration. So public direction, our current direction. Perfect. So what we do now is calculate what direction we want to go. So we go here and on our void update, and we start. If the direction now we want to check if he's going up, down, or left and right, and based on that choose our direction. So our mathf absolute vertical is bigger than 0, so that means if we go up, down, we choose our direction. So current direction is so now we check if it's bigger than 0. So that means if the vertical is bigger than 0, then we're going up, else we're going down. So direction dot up or direction dot down. Sorry, that's vertical, so left or right. Left and right. Perfect. So now we do the same thing for the horizontal. And we change that horizontal, up and down. So now, whenever we press our keys, we can know if we're going up, down, left, or right. So let's check it in Unity. So as you can see here, we have our sprite renderer and our current direction. So I will put my new sprite renderer to the sprent place. So let's check if the current direction works. So up, down, so I have wrong, yeah. So my bad here. That should have been horizontal. And this should have been vertical. Sorry about that. Perfect. So, okay, let's check it out once again. Let's see if this works. So, okay, let's see. So, up, down, right, and left. Perfect. So, okay. So now that we actually get our correct input, we go here. And we actually move our character based on that. So we go and create a new switch, which basically means based on whatever. It's like an if statement basically, but it only works. It only does one calculation. So current direction, and if the direction is up, we what do? We actually get our position and we create a new position. So here we calculate our new position. So we need to create a new vector 3, which will be equal to, vector 2, which will be equal to our next position. At first we want it to be, our next position to be equal to our current position, so transform.position. So the next position will be equal to our transform.position plus our direction. So we will create a new variable which we will call direction, step distance. So we add the step distance times our vector 2 dot our direction, and we break from the case statement. So, and we do that for each direction. So if I left down, we do it down, left, yeah, and left. Perfect. So there's a problem here, and we can't. What's going on here? So let's make this as a vector 2. Let's set this to be a vector 2. Okay, perfect. So now we got our next position, but this will not work since we are always getting a +1, so this shouldn't work. So we want this switch to work only if we are if our current position is actually our next position. So we want to calculate our next position whenever we reach our target. So we will do this if the transform dot position. If our current transform dot position is equal to our next position. So if this is the case, we calculate our new position. Yeah, let's make this a vector 2. Perfect. Okay, so now we want our player to actually move, since we haven't changed really the position of the player. And to do that, we want to create a new variable that's going to calculate how far we are going to be from our actual position. So we're going to call that distance to point, which we will set it to 0. And then we also want to calculate how fast our character should be, so our actual speed, so public float. But it's easier to actually calculate the moves per second than to actually have a speed. So we will have this moves per second, which will be at least 1, I guess. And so now we go to our void update, and we move our player based on how far we are how far we are from the next position. So we go here, we do a vector 2.lerp. So our actual So before we do that, to have a smooth transition, we want to know the previous position we had. So we will create a new variable as well, which we will call private vector2 prev position, previous position. And we will set this as our next position before changing our actual next position. And so here we put our previous position and our next position and our distance to point. So basically this means that if the distance to point is 0, then our transformed position will be our previous position, and if this is 1, it will be our next position. If it's 0.5, it will be in between these two, and so on, so on. So that's it, and now we want to actually calculate our distance to point, which will be our time.delta time times our moves per second. So this means how much time the frame took. So in 1 second, this will be 1. This will be 1, and the moves per second is just how many moves we want to do per second. So if this is 3, then we'll have done 3 moves per second. So before we actually test this, we need to go to our previous position and actually set this as our transformed position, our actual transformed position before we start. And we also want to reset the direction, the distance to point every time we reach a new point and we calculate a new position. So let's try this. We go to our Unity, we can see we have a step distance and distance to point. So we want to put this to 1. And we don't care about this, and let's put this to 1, that's cool. So let's try this. So if we go down, left, if it reaches our destination, but as you can see, it doesn't stop when I don't touch my computer. So we want to actually make sure that if none of these two exist, then our current direction will be no direction. And let's check if this works. Perfect, so this stops when it reaches the destination, so let's make this a bit faster. Okay, perfect, as you can see this moves, basically if I press my keyboard. It's a bit sloppy for now, but to fix that we'll fix this later, but before that we will actually do the animations. So let's do the animations, so we go to our actual Visual Studio, and now we will create a new enumerator, which will calculate our actual animation. So we will call this iEnumerator. Manage animation. Okay, that's a cool name. And now we want to actually get our new our current direction. and we do a switch with it, and now we do stuff based on our directions. So if our case direction is up, we do something, but we need to check how we do change the sprites. So to change the sprites, we will create a new object, which we will call animation cycle. So let's call this public class animation cycle. We need to make this viewable, so we need to serialize it. And here we will have an array of sprites, which we will call sprites. And we will also have an integer, which will say which sprite we are at. Perfect. So now we want to have to actually track our sprites. So we will create a new animation cycle. Which we will call up and down, I guess. So up cycle, down, etc. Okay, so and now we want to create a temporary cycle, which will actually hold what animation we are at. So private animation cycle, current cycle. Perfect. So now we go to our enumerator, and we say our current cycle is equal to our up cycle if we are on the up, and so on. This one now, left and right. Okay. So now that we have this, we want to do our actual animation. So how do we do that? We want to calculate the time that we want per frame, the same way we do the distance to point. So we will create a new variable, which we will call animation time. So we go here, public float animation time. Let's put this to 0. Actually, we don't want this to be public, we want this to be private. And so we want to check if our animation time is bigger than our frame time. So if our animation time is bigger than our frame time, although we want to create a new variable, which we're gonna call a frame per cycle. And so now we check our actual frames. So that's going to be 1 second divided by our frames per second. So yeah, that's that. And now we actually change our sprand sprite to be equal to our current cycle dot sprites dot current cycle dot current sprite. Okay, that's a big name. And we also want to increase the current cycle every time, but if it's bigger than our actual length of the array, we put this to 0. So we increase the current cycle dot current sprite, which means basically we get the current sprite plus 1, and we check if that's equal to our current cycle dot sprites dot length, and if that's the case, then our current cycle dot current sprites is equal to 0, and also our animation time is equal to 0 every time, since we have went over a frame. And we also want to increase our animation time. I think I'm outside somewhere. What's this? Yeah. Okay. So we need our animation time to be equal to our time delta time. And so yeah, that's pretty much what we want to do. And now we wait a frame. And we call our function again. So that needs to be a new wait for frame. And we call our function again. So start coroutine, manage animation, because that's not a function, that's a coroutine actually in Unity. So we need to use the start coroutine function to start it. So before we start it, we need to start it. That's how it starts. So we need to instantiate the coroutine in our start function to always loop, no matter what we do. So let's check it out. let's see if this works. This should have a few problems based on the idle, so let's see. Oh yeah, we haven't put any cycles yet. So let's go to our sprite sheet and let's put our cycles by drag and dropping to the sprites. Down and left, right. As you can see here, we actually haven't used all the animation cycles here. Let's delete this. We actually don't need the left cycle in the end. Yeah, so we don't need the left cycle. We can actually use the right cycle, but actually invert our sprite. So sp_rand.flip x equals true and equals false based on so we save a bit of memory here. So let's check this out. Okay, so that didn't work because we actually forgot to have our frame per cycle to put this up to 4, since we have 4 frames. So let's check it now if this works, which it should kind of. So as you can see, this actually changes. So that's the right, left, up, and down. But as you can see, that's really weird. So let me increase the movement speed. As you can see, this is really slow since this changes before we even wanted to. So to fix that, we go back to our script and we go to our void update and we create a new variable which we will call isWalking, a new bool, solid. And so this will actually check if we're walking and if we have changed directions. And also we want to have a buffer before we actually change our direction. So instead of current direction, we will create a new direction which we will call calculate direction. Which will be equal to our direction just after calculate direction. Yep. But our current direction will be equal to our calculated direction. So this should fix this. And also we want this to work only if we're walking. So if we're walking, so we set this to isWalking true, not true. And we want the isWalking to not be true if we're in direction but not no direction. Yeah. So isWalking equals true, sorry, false. And also our next position should be equal to our actual previous position so that we make sure these two are synchronized. And so now we go to our IAnimerator and we change this only if we are actually walking. So if we are walking, we change our sprites. So okay, so let's check it now if this will work. So we go here and let's say left, this works perfect. Let me increase the speed. Right, okay, this stops immediately. That's pretty good. Yeah, okay. We can actually change this so that, as you can see, sometimes it stops while it's walking and we don't want that. So we can actually change this and put an if else. Our current cycle, our current cycle.current sprite will be equal, our current cycle.sprite, our sprite will be equal to our sprite.0 plus we will make this 0 and our animation time will also be 0. Okay, so let's see if this fixes it. Perfect. So as you can see, it doesn't stop at walking. Let's create list 3. Perfect. So this works perfectly. Although it does seem to be a little bit laggy. Okay, so to fix this, we actually go to our script. And here that we change our animation time to 0, we actually need to change that to 1. So it's always ready to change animation. And to make it even smoother, we can actually create a new cycle, which we will call animation cycle.previous cycle. And we can check if this is, we can check if our, let's save our previous cycle to be equal to our current cycle, not direction. For some reason I think I have previous cycle, yeah. And if the previous cycle is not equal to our current cycle, so that means that our direction has changed, then we actually change the current sprite. So let's check this out, if this works. So let's say this should work fine. Perfect, that works fine. As you can see, it changes direction immediately whenever we press up, down, right, left, etc. So right now, as you can see, we have two main problems. When we press left and right immediately, it doesn't change immediately, which does create some really weird, as you can see, this keeps walking, which this should not be the case. So to fix that, we go to our Visual Studio, and we need to calculate if our new input is actually opposite of our old input. So if we're going up and we press down, we want it to immediately change and not go first down and then up. So to do that, we will create a new direction, which will be called, no, that's actually our calculated direction. What we want to do is check if our calculated direction is not equal to our current direction. And if that's the case, we create a bool that says to the script to change directions. So we will go here and we will create a new bool, which we will call switch directions, which will be false. And now we create a new switch statement for our calculated direction. And in case we are direction.up and our current direction is equal to down, so if our current direction is equal to down, then this will be true, or else it will be false. So let's break this. Let's do this for the other 4 directions as well. So this is down, we want up here. This is left, and let's go right. Right and left. Perfect. So what we want to do now is actually change our distance to point. So if the player is here and he's going up to here, and he's like 0.2 to go to 1, when you go down, that's basically 0.8 of the distance. So we want to swap that distance. So if we switch the direction, we want our distance to point to be equal to 1 minus our distance to point. And our switch direction is obviously true. And so now we can actually change this to be equal to our switch direction and check now here if our player has reached his next position, to actually put our distance point to be equal to 0 and the switch direction to be true. Okay, so let's see now if this works. So it goes left, right. No, this does not work, obviously. Okay, so that didn't work for 2 reasons. First of all, because we have forgotten to delete the distance point to be 0 whenever we switch. And the second reason is because we don't want to use our transformed position, we want to use our next position as our point of reference. So we go here and we swap the transformed position to our next position. So this should work. Actually, let's also change the current direction to be looking down when we start the game. So let's say, okay, that's perfect, yeah. As you can see, this is really smooth. So whenever you want to change direction, we go up, down, left, right. Yeah, that's really smooth. So final thing we want to do before we finish, we want to check for collisions. So let's create a new grid, which we will call our object grid. So sprites, TileMap, rectangular TileMap, object. And let's actually paint this with our objects. So let's put some rock here, 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 here. And yeah, it looks good. Meanwhile, while we're talking about our tilemaps, we can also create a new collider tilemap, which we will call collider, sprites, tilemap. We can use any sprite we want here, since we're not going to render it. So let's use this tile map here. As you can see, these are not aligned, so we need to align them. This is at 0.5, which we do not want that. This is also at 0.5, which we don't want that. So, okay, let's check it out now. Yeah, perfect. So like this and like this. So now we go to our objects, to our collider, and we actually create a new TileMap collider. And we disable the renderer as well. Perfect. We can also use the shadow that I have provided for the character, since we are at it. Let's move this here. Let's also make it to be a bit lower than the character. Yeah, perfect. Okay, so now we can actually start by using our colliders. As you can see here, we just go through the collider, which is not what we want to do, obviously. So to fix that, we need to go to our script. And now we will create a new function and a new actual class, which will contain our directions. So public class, we will call it a collision direction, and it will just contain 4 balls, which will be the ball up, the ball up, down, left and right. Perfect. So now we'll create a new function that's going to return our collision direction. So this new function will be a collision direction check collision will be the name. Perfect. And we will actually raycast through to our character. So if something is on the left of the character, we will set the left component to true, and so on, so on. So we will create a new collision direction to be a new collision direction. Perfect. I have no idea why this is. Oh yeah, forgot the name. Call. And so now we create our raycast. So our raycast hit will be equal to our physics.2d.raycast, and now we raycast from our character plus our vector dot up plus our vector dot up, and we will raycast this at on the up direction, and this will have a distance step. Yeah, perfect. Okay. And now we check if the raycast hits anything. We will set the up function to true. So we go here, and we set the collider, the up boolean to be equal to if our collider is not equal to null. So that means it has hit something. Okay, and we do that with every single hit. So we don't need the raycast hit here. And here we go down, left and right. And we do the same thing about our colliders. And we return this collider here, this collision direction anyways. So we go to our update, and we call the collision direction to be equal to our what we're going to call it. Let's call it direction collision again. So private direction collision. These are really bad names, but anyway. So the direction collision will be equal to our check collision. And now we go here, and here where we change the position, and we check if the collision direction, if the direction collision dot up is not true, then that means we can actually move. But if it is true, then that means we cannot move. So we put this for all our directions. So down, I have no idea why I changed language, left and right. And let's check if that works. So as you can see, we're moving left, right, and that's bad. So let's actually move our character. No. Let's put this at 1 and let's check if that's the problem. Yeah. So if you go left, right, left, barely. For some reason, I think we have forgotten. We have put a collider here. Let me check. Yeah, there's a collider here. Let's remove that. Right, let's remove the collider. Okay, so let's check now if it works. Okay, so as you can see, it goes to the left and right, and it doesn't move it if there's a collider in there. So yeah, that's pretty much it with the collision detection and with the 2D movement anyway. So to recap, we have a collider, sorry, we have a movement that goes up, down. It changes immediately directions whenever we change, if the direction we put is opposite. And we also have a character that can move left, right, and it detects collision if there is a collider in front of him. So that's pretty much the basics of 2D movement, 2D movement. So to recap, we have a movement script that goes up, down, left, and right, and it detects collision, as you can see here. It can't move after the rock, and also it changes the direction real quickly if we need to, since the opposite direction doesn't really affect us. And in general, it's pretty responsive, and it will be pretty well suited for a 2D game for the pixel art direction, and you know, if you want to make a retro top-down game. So thanks for watching, and I hope you liked the video.